happens to be in his course, same basically class. So if you need some more examples, I'll give you his name if you want to look at his videos.
Okay.
But there's kind of a process here, and we don't necessarily do it in the order that they have here, but you may have to factor. This one's already been factored. And I usually like to start with the domain. Does it even ask for that? It does not. Good. Okay. All right. So the first thing you look for are any factors that cancel. And if they cancel, it becomes a whole. So the whole, though, you got to be careful here with it. It's where the factor that cancels equals 0. So at x equals -4. And then what I talk about is I talk about the reduced form of this rational. It's the f of x equals -5 parentheses x plus 2 over x minus 3. And you need the y value of the whole also. It's not just at x, it's an x and a y, it's a coordinate. And you get that by taking this x value and plugging it in for x in the reduced form. And we're mostly going to work with the reduced form at this point. So it's good to just sort of think, okay, this is what I've got to work with. So that's -5 -4 plus 2 parentheses -4 minus 3. And then you just got to reduce here some fractions and just be careful with signs. So it's 10 over -7, which isn't a great number, or -10 over 7. What is most important is that you say, oh, it's a little bit bigger than -1, or a little bit further down than -1, but not quite to -2. And are you allowed to use a calculator on this or not?
No.
No calculator. Okay. Darn. All right. So the graph as you go, and we're just going to put a really big emphatic hole at -4, -10 over 7. So right there, -1, 2, 3, -4, and somewhere there. We'll come back to that later. Is there anything you'd like me to clarify on that for you?
No.
Okay, so after you do holes, and after you go to the reduced form, this reduced form over here on the right, which I'm going to copy, we now want to find vertical asymptotes. So vertical asymptotes come after holes. You have to find the you have to set the denominator equal to 0. So denominator equal to 0. So a lot of rules here, a lot of Quizlets or flat review cards, whatever you want to do to remember this. But you'll find there's one at x equals 3 is your vertical asymptote. So that's down here, over here on the right. Definitely a good idea to label the equation. And then what I like to do is put some arrows in to help connect later on. So it looks like you have that vertical asymptote. You did get the whole, just doesn't look like you put it in the right place. You didn't finish it off yet. So do you know if your instructor wants you to specify like removable versus non-removable?
Well, she usually puts like, well, yeah, she wants to know which ones are removable and which ones are non-removable.
Okay, so to summarize, holes are always removable. And these are from the math perspective, and vertical asymptotes are always non-removable. There's no exceptions. You don't have to worry about any weird,
Right.
Okay. So from here, the next thing that I like to find is the horizontal asymptote, which is the end behavior, but really it comes after vertical. You kind of do those together because they help kind of frame the graph and create boundaries. So you look at that reduced form again, and because they have the same degree, it's the ratio of the leading coefficients. So in this case, it's -5/1.
Right.
And let me know if I should add any more to that. But whenever it's the same powers, you just use the numbers in front of x on both the top and the bottom. And then I like to graph it, right away, get it on there, and then add some arrows in because we're probably gonna connect later on.
Okay.
Then I like to go to the y-intercept, which is when x equals 0, and then go to the x-intercept, which are the zeros. We'll get to those, but you go to that reduced form and you substitute 0 in for x. So you're looking at -5, 0 + 2 over 0 - 3. So again, not great. You get -10 over -3. You get 10/3. Then you need to be like, okay, that's bigger than 3, but it's not quite 4. Your instructor's grading you on the number and then the reasonableness of where you put that point. So 0, 10/3, somewhere up there, but that it's a literal point. You fill it in.
Right.
Right. And then we move to x-intercepts. X-intercepts are when y equals 0, but more generally, it's setting the numerator equal to 0. And again, we're doing the reduced form. You don't go back to the original and set the original equal to 0. So it's -5x plus 2 over x - 3. So you set that top equal to 0. And you can distribute in, but it's actually better to divide out that coefficient first, because it ends up being 0 and x equals -2. And I do see you put a dot there on your graph at some point for that. So these are the zeros now.
Okay. So it would just be x is -2.
And y is 0.
Oh, right.
So the zeros, both the x, that's why I do them together, because the y-intercept is a point on the graph, and same with the x-intercept. They're points on the graph. So there's a literal point right there. Boom.
Okay.
All right. So now this is just the way you've got is so disorganized on this paper, not you, but just it's hard to, like, we've got a nice graph going, but I really need more space up here. So the like, I guess let me just try and squeeze this. I'll show you what the answer is, but I gotta actually just kind of go do something more like this. So that's the graph. I mean, I don't know if that's clear or not, but it's got to go through those points. And then over here, it ends up being this way in the lower right. And we get that. Well, I'll show you how to do that, but I want to graph it first. We get that by testing points. So if you notice the last thing there, it says test points, describe the end behavior. Let me grab that in limit notation. So a couple of ways to do this. So let me actually redraw the graph so you can see how we do this. So if we're not as careful, we had an x-intercept, we had a y-intercept, we had a hole, and we had an asymptote here. And we had a vertical one down here. So the problem is that you have all these like regions that you're supposed to look at. So like, for example, this is a region over here that you're supposed to test a point in. You're really supposed to test one here, test one here, test one here, and then test one here. And it becomes kind of obnoxious because it's a lot of testing, but that's what you're supposed to do. Like that's the
Right.
I may need to just take a 30 seconds here. Give me just a moment here. Be right back. Okay, I'm back. So the point is, I guess, is like you want to try to avoid having to test all these different regions. And so that's why in the graph here, I think I've said this before, like when you get two dots, they have to connect and holes have to connect as well. And these arrows have to connect. So you really don't have to test all of these regions up here. But that's the idea with this is like, you're supposed to pick a point that is greater than 3. Okay. Maybe like 4. And then you're supposed to test something in here like 1 and then -1. And then between 2 and -3, so -2.5 and then -4. And were you actually doing that in class? Do you remember if you're actually testing all those points?
Yeah, we are.
Okay. So that's where there's a lot of work to be done. So you go back to your reduced form equation. So let me grab here. And what's nice though, what's I think is actually like when you get comfortable with this is you're just looking at the sign. Okay. You're just looking at when you take this number like 4 plus 2 is positive. 4 minus 3 is positive. So it's a negative times a positive over a positive, which produces a negative. And what that tells you is it tells you, oh, it's down below here. And then similarly with 1, and were you actually getting numbers out or were you just looking at the sign?
We were getting numbers out.
Okay, so the numbers help you to graph, like if you're not sure where to put a point, but here's the thing, you can't cross the horizontal and vertical asymptotes. You just can't cross them. So you don't necessarily need to know that, you just need to know whether it's positive or negative because it's negative. It's got to be down here. You might say, well, what about this region, Matthew? Well, it can't cross to get there.
Okay.
And this is just a really awkward example for all this, but so similarly with 1, I mean, yeah, you can get a number out. You can say it's 1 plus 2, which is 3. 1 minus 2 is -2. But really, it's the sign of the number you care about, and you just put that in this region and so on. Okay, but let's actually talk about let me get the graph, and let's talk about the how to write the behavior again. So let me just make a quick sketch here of your graph. So you've got this, and then you've got this up here. Okay, so we need to do a couple of things here. We need to say as x goes to infinity, but your instructor wants to use limit notation. So you can't use that anymore. You've got to say the limit as x goes to infinity f of x. And what this means means x going to the right, x to the right. So that's this part of the curve down here, because this one up here, it keeps going up forever. And this one down here goes to the right. So the question is, well, what is the y value? What is the y value that it approaches? And we already said there's a horizontal asymptote at -5, so that is -5. So generally at the endpoints, it approaches the horizontal asymptotes.
Okay.
So then similarly, limit as x approaches infinity f of x going the other way, negative infinity, you're tracing in the other direction. Like, all right, if I go left, what does it approach?
Negative infinity.
No, because it's not going down. It like x is approaching negative infinity, but what is the y value that it's approaching?
Oh,
It's always the y value.
yeah, it's -5.
It's -5. So the shortcut here is that the end behavior is always, it's always to the horizontal asymptote, always.
Okay.
All right, now middle behavior. So the middle behavior, horrible. We got like the never-ending problem here, because it's just so many things here. So the middle behavior wants to know what's going on at the asymptotes, at the vertical asymptotes. And we know that it's basically doing one's going up and one's going down. I'm just making that brief sketch again of this. So this is the limit as x approaches the vertical asymptote value 3, but we have to do it two ways. We have to do it from the right, and that plus means from the right. That's a calculus thing. And then the minus down here means from the left. Okay, so the first one, 3 plus, it's from the right. So you have to come from the right. It's from your, wherever you're coming from the right. And how far down does it go? It goes to negative infinity. And these are the ones, the middle ones always approach plus or minus infinity.
Okay.
There are a few exceptions, but now from the left, from the 3 minus, from the left means you're tracing it from the left. Like my cursor's moving left to right. And you're like, all right, well, how high up does it go? It goes to positive infinity.
Okay.
All right, so rather than going through an entire new problem, I want to just give you one here to try on your own for just the end behavior, just to see if we can get this part down. This one. All right, so just let me grab, if I can do the settings on this. Let me go dashed. Yeah, that's good. And then dashed, that'd be really good. Okay, and then we'll go one more, settings, dashed, done. Okay. All right, so let me snip this in. So I'm snipping in the graph, and that's why I just took a moment here to get this sort of consolidated. So we want to focus first on end behavior. Okay, and just so this is y equals 1 line here. So we're focusing just on the end behavior, just on what happens, the limit as x approaches infinity, and then the limit as x approaches minus infinity for this. And assume it's f of x. So sorry, let me know don't have enough space here. Let me just tighten this up a little bit. Okay. So go ahead and give this a try. What goes in those positions?
I got as x approaches infinity, y approaches 1.
Yes, now, just to be clear, this is what your instructor is expecting for
Yeah.
your answer, or if they gave you it as y, but f of x is fairly standard. How about the other way?
I got as x approaches negative infinity, y approaches 1.
Yes, they generally approach the same value, but not always. Okay, now let's do the middle behavior. Okay, so I'm going to re-snip this down here. Okay, and just for clarity, this is x equals 4, and this is x equals -1. So I want the limit as x approaches 4 from the right, and the limit as x approaches 4 from the left. And these are both f of x's, because that's the only thing we got. So let me know what you come up with for that, please.
Okay.
How are you doing on this one?
Okay. So I got as x approaches 4 to the left, y approaches -1.
Okay, so so 4 is this purple line. You're seeing the purple line, right?
Yeah.
Okay. Now do you want to do from the left or from the right? Because I heard from the left.
Yeah.
So from the left means I'm left of it, left of it, left of it, left of it. Now I'm really close to it. What is it approaching?
4.
No.
Oh, negative infinity.
Yes, it's always the y value. Yes. And that's why, if I was right there, I would have you take your finger and just trace, like your finger painting, basically. Like, all right, I'm gonna trace. I'm left. I'm left. I'm left. I'm left. I'm left. Okay, now I'm really close to it. Now what am I approaching? Approaching. Okay, I got it. Same thing from the right. From the right, put your finger there. You're tracing, trace. And it's like, oh, now I know where I'm going. Positive infinity. And this is, to be fair to you, this is a calculus concept. This is something you will see in the first week of calculus. But we can't comment on why you're doing it now. We can just say that you are, and so you got to know it. So let's try another one here. There's a little more. So it's the limit as x approaches -1 from the right. Limit as x approaches -1 from the left. So go ahead and take a look at that and let me know what you come up with.
So from the right, it would be positive infinity, and from the left, it would be negative infinity.
Yes.
Okay.
So the middle behavior, in between behavior is always to, it's almost always to a positive infinity or negative infinity, whereas the end behavior is always to a number.
Okay.
All right. So you can see how long these questions take. So you're not going to get you're not going to get a ton of these. I mean, one or two, I would think. I mean, it's really better for a quiz because you can do one and you can really work through it. Okay. So new question here that I'm seeing. One of the things I would advise is to, is to factor out only one thing at a time. So like in the numerator, yeah, it does become what you have here, but I would factor it out into x squared minus 9 first. And then deal with the, next layer of factoring. Okay, so the numerator is difference of squares. And we know that because it's subtraction, there's two terms and 9 is a perfect square. That's really key. So your perfect squares are 4, 9, 16, 25, 36, so on. Okay, so it always becomes a minus b and a plus b. So you got x minus 3, x plus 3, which I think is what you're about to get to. And then in the bottom, yeah, it's x plus 3, x minus 1. And you will be expected to do that. I mean, that's something you've learned in previous classes. So you can absolutely do that.
Okay.
Okay, now we look next at for holes, and holes are where anything cancels. So there's a hole at x plus 3 equal to 0, and you need both the x and the y. So we know that x is -3, solving for x, and then you use the reduced form. So you're like, all right, my new f of x is -2 x minus 3 over x minus 1, -3. And then to find the y value, you take that -3 and put it in for x.
Okay.
Okay, so you got -2 times -6 over -4. This one works out nicely. 12 over -4 is -3. So it could be that both the x and the y values are the same. Sure, no reason not to. Now, I would immediately graph this, and let me actually grab your graph, because I noticed that you're just sort of given free form. I don't like that one. Kind of like that one. All right. Okay, so -3 is our hole. So we'll just put, all right, it's roughly there. There's your hole. Make sure it's not filled in. Okay. And then we move to vertical asymptotes. So vertical asymptotes are where the denominator equals 0. Okay, so you're going to set x minus 1 equal to 0 and x equals 1. It is an equation. So x equals 1. That. And then horizontal asymptotes are next. So can you tell me what you think the horizontal asymptote is in this problem? It's like the first one we did. So if you want, I can scroll back up, or you can look at your notes.
Would it be y equals, wouldn't it be a -2 over x?
It doesn't have x in it.
Oh, 1.
Yes, very good. Yeah, it's the ratio of the leading coefficients. Okay, so you gotta be careful how you made this circle. Let me just move mine down just a little bit, just to make it really clear. Yeah, it's there. There's the y equals -2. So I know we're doing this out of order than what you're seeing on there. Let me just address that here. So the whole is removable. I guess I never even said that. The whole at -3, 3, that's removable. Holes are always removable. You can always fill in a hole. And vertical asymptotes are a non-removable. You do not have to say anything about horizontal asymptotes, though they're not discontinuities. Which may sound odd, but that is the case with them.
Okay.
All right, now we move on to my preferences, y-intercepts and x-intercepts. These are both ordered pairs. So y-intercepts are when x equals 0, and you're going to use that. You're going to use that reduced form, -5. What did I say here? -2. Let me just grab the function again. So you're putting 0 in for x. So it's -2, 0 -3 over 0 -1. So that becomes 6 over -1 or -6. So when x is 0, y is -6. That's an ordered pair, 0, -6. So what you have to remember, all right, this y-intercept means x is 0. You get 5 or 6 things for each of these to remember. So 0, -6 gets you down here. Roughly, we'll say. I don't know, maybe it's a little too low, but right there. X-intercept. What do you set equal to 0 to find the x-intercept? Can you look back in your notes, see what you find?
You set y equal to 0.
You do, and that's totally correct. Okay, which really means you're setting f of x equal to 0. But in this types of problems, what's sort of the shortcut for that? So you actually just set the numerator equal to 0.
Oh, okay.
And that's yeah, this is true, but it's really the numerator setting equal to 0. So -2 x -3 equal to 0. Could you solve that for x for me?
Yeah. It would be x equals 3.
X equals 3, y is 0, so the ordered pair is 3, 0. And you go back to your graph, you're like, all right, 3, 0, I got it, it's right there, boom, feeling good. All right, and so I didn't do this earlier, but I'm going to put the arrows in now at the asymptotes. Do you feel like you could try to connect these, or is it still unclear how to do that?
I feel like I could.
Okay, so some rules. You're not allowed to cross the vertical or the horizontal asymptotes. And like, it does have to connect those two. So it's like all right, well, let me see what like I can do, and then see if like other things become more clear. It's kind of like putting together like an IKEA thing. Sometimes you're like, all right, let's try that, see if we get together. And or Lego, if you ever did Legos. But you also need to connect the arrows, and you know, you can't like double cross. You have to make it look smooth. And maybe you see that it looks something like this here. Now, because it has to cross there, that's the only possibility on the top right in the red.
Right.
So generally all of your graphs are either going to be top right, bottom left, or it's going to be top left and bottom right. Yes, there's exceptions. You know, we can't cover them all, but that would be everything here. Okay, so let's grab this image and let's talk now about end behavior. End behavior. So the end behavior is as x goes to infinity and as x goes to -infinity, but they want you to use limit notation. Limit as x goes to infinity, f of x. Limit as x goes to -infinity, f of x. Could you give this a shot here for what you think the answers are.
It would be as x approaches infinity, y approaches -2,
Yes.
and as x approaches negative infinity, y approaches -2.
Yes. Now, the instructor, I believe, is expecting this. Because it says limit notation. I like what I heard, and I'm not being critical on you, but this is what I heard, and this is true, and used f of x instead of used y instead of f of x, but I don't think that they will. I'm pretty sure based on what I'm seeing, like they want the limit notation, not this end behavior notation. But you know, you're in the classroom, you know, confirm with your notes.
Yeah.
Okay, now next one is the middle behavior. The middle behavior. All right, so the middle behavior is the vertical asymptote. So it's the limit as x approaches 1 from the right, and the limit as x approaches 1 from the left. Go ahead and take a look and see what you come up with for that.
Would it be infinity and negative infinity?
Which one? Which one is positive infinity?
The first one.
Yes. Very good. Okay, good job there. So let's look at, let me ask you, so let me try to get you to do some of this on your own here. So let's say that f of x equals -4 x minus 1 over 2 x plus 3. And let's assume that this is also here. Could you do the following for me? Could you find the x and the y coordinate of the whole?
Yeah.
If you have questions, of course, please ask, but
Um,
do you have
would
the
it
x
be,
coordinate for me?
yeah. Would it be -2?
That's correct. How about the y value? Did you come up with that?
Yeah, I got 6.
Oh, it worked out nicely. Let me take a look here. So it's -4 minus 2 minus 1 over 2 times -2 plus 3. So the numerator becomes -4 times -3. Denominator becomes 2 times 1. Yeah, it does actually work out nicely, shockingly. Yeah, it's 12 over 2, which is 6. Perfect. Okay, very good. So now let's look at the reduced form. I'll ask you some more questions here. I'll try and do it in the order we've been doing it in, so you can see why I'm showing you this method, this approach. I want you to tell me the horizontal asymptote, please.
Would it be -2?
It's an equation. What is the equation of the line?
Oh, it'd be -4/2.
No, it's y equals -2. Yeah, that's correct. And
Oh.
sorry, I did this out of order, so pretend like we
Okay.
didn't do that. What is the vertical asymptote? And it is an equation again. It is an equation. You don't get to just say, negative to negative, where you have to give, variable equals number for it.
I'm like completely blanking.
Okay, set the denominator equal to 0.
Oh, right. So would it be -4x minus 1 equals 0, or would it be
The
-4
denominator,
minus
the
1
denominator
equals
is the
0?
bottom. You're setting the bottom
Yeah.
equal to 0.
Yeah, that's what I did.
Okay, what did you come up with?
It would be undefined.
Right, where? What value makes it undefined?
The 0.
Yes, so Paige, what I'm asking you to do is write 2 parentheses x plus 3 and set it equal to 0 and solve for x.
Oh,
Yeah. Give that a try. Let me know what you come up with.
it would be x equals -3.
Yes, x equals -3. Very good. So there's your vertical and your horizontal. Okay, so now let's go back to the reduced form again. And I want you to find now the y-intercept. Y-intercept. And look back in your notes if you need to. And if you want to confirm with me, you can. But let me know what you come up with.
I got 0 2/3.
Okay, so when x is 0, that's an ordered pair like you just said. Y is 2/3 minus 1, so you get 4. Yes, very good. And then the next one is the x-intercept. Next is the x-intercept.
Okay. It would be 1 0.
Perfect. Very good. Very good. Okay, let's look at one of your next problems here. All right, so now when you look at the numerator of this, new problem here, problem 3, do you see that there is a greatest common factor in the numerator?
Yeah,
What is that greatest common factor between both?
3.
It's actually, it is 3. You're not wrong, but the preference is to go to -3.
Oh, okay.
So it's like whatever's in front of that. So what goes inside parentheses if you factor out a -3?
X squared minus 4.
Perfect. And do you see now that this is difference of squares?
Yes.
Okay, can you tell me how to factor that, or can you tell me the result when you factor that, please?
It would be x minus 2 and x plus 2.
Very good. And then on the bottom here, you're trying to find two numbers that multiply to -6, but they add up to -1. Any idea what that might be?
-3 and 2 and positive
Yeah,
2.
x minus 3, x plus 2. Since we don't have a ton of time here, but we can run through some of this. What is the x value of the whole only? What is the x value of the whole?
It would be -2.
Yes, perfect. And to get the y value, which I'm not going to ask you to do, you put the x into the reduced form.
Right.
So grab the reduced form. Okay. So there's your reduced form. Now let's do vertical asymptote next. What is the vertical asymptote? And if you need a reminder, let me know, but you're setting something equal to 0.
It would be x equals 3.
That's right. The horizontal asymptote is y equals -3/1 because there's really a 1 there. Okay. And then the y-intercept is putting x equals 0 in. Just going to get this down for you in case you want to look at it later. 6/-3, which equals -2. And then the x-intercept, you're setting the entire numerator equal to 0. So that -3x minus 2 equals 0. And you end up getting x equals 2, y equals 0. That's an ordered pair. And then similarly for the y-intercept. So if you have time, it'd be great for you to try redoing some of the problems we did today. And like I said, the student here, I just write his name down. It's Jaden R. He's doing almost the exact same thing you are, but not in your school, as far as I know. I think he's in Phoenix or California. I really have no idea, but some more practice problems there if you want.
Okay. Thank you.
That is it for today, Paige. Thanks for doing it on a Saturday. You're a math nerd now.
Yeah.
No, I really appreciate it, and let me know if I can help you again midweek. Love to keep helping you out with this stuff. So
Okay.
enjoy the rest of your weekend. Okay, bye now.
You too.